Curiosity gets a rock stuck to its drill. NASA releases over 12,000 images of Artemis II. The new Pandora Space Telescope sees first light. How Io's lava lakes produce more energy than we thought. And in Space Bites Plus, a meteorite that is very similar to the planet Mercury. All this and more in this week's Space Bites. Well, it's been a couple of weeks since the end of the Artemis II mission, and like many of you, I'm still excited about this mission. I know Hank Green has just been going off about how cool the mission was and has been regaling us all with a lot of the sort of excited discoveries that he's been making looking through the images. And NASA just dumped a huge schwack of images that we can all look through. So they've just released over 12,000 images from the Artemis II mission. We've got images of the Earth, images of the moon, images of the crescent Earth, crescent moon. There are cool star trail images, images of craters seen from directly overhead as the astronauts were flying by. Really amazing images showing the terminator of the moon, seeing the horizon of the moon. It's just an incredible set of images. Now, there are a lot of images that are exactly the same. Like probably someone took 50 images, click, 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 click. But if you browse through all of the images, you're going to find some that are just absolutely stunning, incredible. Ones where the sun is just peeking over the horizon of the moon. So just to kind of celebrate, we're going to show you a bunch of examples through this episode. There's just too many to go through. And instead, we're just going to hide them randomly in this episode. And as you watch the episode, you'll see more and more of the images from the Artemis mission. We're going to put a link down in the show notes where you can go directly to the full list of the images, and then you can find the ones that you like the best. But it's incredible. Go ahead, dig through it, enjoy all of this imagery from Artemis II. And if you want a fun game, go ahead, tell us how many of the images you saw. Some of the images are going to be obvious. Others we're going to hide a bit in this episode. So go ahead and put the count for how many of the images you saw into the comments down below. So NASA's Curiosity rover was taking samples across the surface of Mars, as it does. And of course, it has this robotic arm, and then it has this auger at the end of the arm. And then it uses this to scour away some of the surface material, and it can look at the composition of the rock that's underneath. And so it was using this instrument on a rock when the rock broke off and stuck to the bit at the end of Curiosity's arm. And there are these hilarious video clips of the arm with the rock rotating at the end of the arm. Now, this is a problem. The rock weighs about 13 kilograms. It's about half a meter across, sort of a thin slab. And after they tried sort of vibrating and shaking the end of the robotic arm, they weren't able to drop it. They started to rotate it. It took them about 6 days to figure out and carefully plot out how they were going to get this rock off the end of the robotic arm. And in the end, it did dropped off, and now Curiosity can continue to take more samples. But this is sort of very familiar to me. I work with a lot of power tools, working with a chainsaw. You get your chainsaw stuck in a tree, and it's very annoying. And I'm sure, for Curiosity, just wanting to do science, man. I always love it when a telescope gets first light. And this is a mission that we have been watching for quite a while. We're talking about the Pandora Exoplanet Survey mission. So this is a spacecraft that is part of a new incentive from NASA. They're calling these the Pioneer Program. And these are missions that are designed to answer a very specific science question at a very low budget, something that's less than about $20 million. And this is the first one. After Pandora, there's another one called Aspera, which is going to be just studying galaxies in extreme ultraviolet, and it's due for launch in August. But Pandora has launched, and now this space telescope was able to capture its first light. Pandora is looking at 20 exoplanetary systems, studying the planets that are orbiting around them. And these are known planets, and so it's just dedicating lots of observation time to these very specific planets, trying to learn as much as we can about them. The Space Telescope has a 45 centimeter primary mirror, and then it has two instruments, a visible light instrument and an infrared instrument. In fact, the infrared instrument is a spare, essentially a backup of one of the instruments that's on James Webb. So it's packing a very powerful science instrument to do this work. It's going to do follow observations of 20 known transiting exoplanets and do about 10 measurements per target. And each observation is going to last for about 24 hours. And then from this, astronomers are going to try to learn as much as they can about each of these individual planets. And then they'll use what they've learned not only to just understand these planets better, but also to then design other instruments and experiments for future planet hunting missions. Now, I have done an interview with one of the people behind the team, Dr. Ben Horde, and we'll put a link down in the show notes. Now, this story was written by David Dickinson. One of the big problems in exoplanetary observations is that you're trying to look at the planet while it is transiting in front of the star. You're looking for these really subtle variations as the atmosphere is passing in front of the sun, and that you can then measure the chemical abundances in that atmosphere that'll tell you what the atmosphere is made of. But a problem that is just getting bigger and bigger, and this is something that I've identified, I've done interviews about this, that the light and the variations coming from the star is causing a lot of noise that astronomers are having trouble untangling from their exoplanet observations. So the stars have things like sunspots or convective motions or oscillations and magnetic activity, and that these can produce variations that can last for days or longer and can just completely overwhelm the sorts of variations that astronomers are trying to sense with the atmospheres. So astronomers have decided that they're going to study a star in incredible detail and use these observations pushed through the kind of telescope that would be doing exoplanetary observations to understand it better. What is the best star that we have available to us? The sun. And so there is this new instrument called the Paranal Solar ESPRESSO Telescope, or POET. And so this is an instrument, a telescope, looking at the sun, and then they're taking the light from that and they're pushing that into the ESPRESSO instrument, which is this really powerful tool for measuring polarized light. And this has been used to directly observe exoplanets and a bunch of other observations. And this is part of the Very Large Telescope, which is one of the largest telescopes on Earth. And so from all of these observations, the hope is that they can then really in detail characterize what are the kinds of variability that you get on the sun, and you can use that to try and remove that noise put that into models so you can remove the noise from the observations of exoplanets. In April, they collected first light on the telescope and the instrument, and so now this work is truly underway. We've got a story about this from Matt Williams on Universe Today. Io is Jupiter's closest large moon, and it is the most volcanically active place in the solar system. There are about 400 lava lakes on the surface of Io at any one time. And the way these lakes look is actually a little bizarre, but if you look at them, you'll see this sort of solid crust on the lake and then this ring of fire around the edge of where the lava lake is. So what happens is you get this flow of lava up to the surface, but it is very cold out by Jupiter. And so as the lava is sort of radiating its heat off into space, it cools down, it solidifies, and so you get this crust over the top of the lake, but all of the fresh material is still around the very edges of the lake. And so while the center can be around 220 Kelvin, which is below 0 Celsius, the molten parts can be 900 Kelvin, so very hot. And so planetary scientists want to understand how much heat is making it out of these lava lakes. And so there's been long-term measurements of this. Like, I'll give you one example. There's one called P63, and it was originally estimated that there was about 7 gigawatts of thermal energy coming off of this lava lake. But new models have been developed looking at how this works, and it actually turns out it's probably 10 times more. It's more like 80 gigawatts of thermal energy coming off just this one lava lake. And so by coming up with better models to understand how much heat is coming off of Io, you can then get a better sense of what the internal structure probably looks like. How much heat is being generated by the tidal interactions between Io and Jupiter and the rest of the Jovian moons. And we've got a story about this from Andy Thomaswick. So we now know that Mars has lots of glaciers around its mid-latitudes. These were discovered by spacecraft in orbit around Mars. And what you've got is you've got a glacier made of water ice, and then it has a layer of material, of rock, regolith on top of it. And that material then prevents the water ice underneath from sublimating as it warms up. It kind of acts like a blanket, but it also obscures it from our perspective. So it just looks like rock or sand on the surface of Mars, but it's actually a glacier. But we have situations like that here on Earth. And recently, scientists went to 2 locations on Earth. They went to a place in Alaska and they went to a place in Wyoming where there are glaciers. Glaciers that are tens of meters thick, but then are also covered by a couple of meters of just rocky material. And that obscures the glacier from view. And so they use drones equipped with radar to scan the edges of these glaciers to map out the thickness of the covering as well as the thickness of the glaciers themselves. And this technique seems to work very well. And so this could be applied to Mars. And of course, we've talked about this upcoming mission to Mars that could fly in the next couple of years called Skyfall, where you would send 3 helicopters to Mars. They would come in from orbit and they would start to fly around on Mars doing various scientific observations. It would make sense that you could equip one of these with this radar instrument to be able to scan and search for these mid-latitude glaciers. And of course, if we ever do send humans to Mars, finding water ice at the mid-latitudes is going to be huge. This is the most important resource that they'll be able to get their hands on. And so if we can find these glaciers, map out their thickness, map out their density, find out where they're located, then human explorers can go to these locations, drill down through the rock, and get to the water ice. We've got a story about this from Andy Thomaswick. Every week we do a vote on our channel where you tell us what you thought was the best space news story of the week. And the winner last week was that there will be no cuts to NASA's budget. So thank you everybody who voted last week. Of course, we are going to put the poll for this week into the post tab on our channel. So go there, check it out, vote. Of course, subscribe to the channel, click on the notifications bell, obey the algorithm, obey the algorithm. Once again, we are going to talk about some of the science from Comet 3I Atlas. You remember that? I know last week, some of you were surprised that I brought up that old thing. Well, we're going to keep talking about 3I Atlas until there is no more science to squeeze out of the third interstellar object that's ever made its way through the solar system that we have detected. This week, we got an announcement of observations from the Subaru instrument, which is a Japanese telescope in Hawaii. And like many of the big telescopes, they were observing 3I Atlas after it completed its closest flyby of the sun, its perihelion. And Subaru was measuring the ratio of carbon dioxide to water in the coma, which is this cloud that surrounds the comet. And they found that the ratio was much lower than earlier observations that had been seen by space telescopes. And what that tells us is that 3I Atlas has these layers, that the outer crust of the object, which sublimated first, had higher ratios of carbon dioxide to water. But then the internal regions, once it had done its flyby of the sun, started to heat up, then you got this lower ratio. And so this, again, is giving us more insights about the solar system that it formed in, as well as what it might have experienced, or really didn't experience in the billions of years that it flew through the cosmos until it finally reached the solar system. We've got a story about this from Matt Williams. Uranus and Neptune are classified as ice giants, which is that if you could crack into Uranus and Neptune deep down inside, you would find substances that form ices here on Earth in cold temperatures. You've got water ice, you've got methane, you've got ammonia. But that really just doesn't do it justice, because you've got this incredible high pressure, thousands of gigapascals of pressure. You've got high temperatures, thousands of Kelvin, and those turn water ice, ammonia, methane into very bizarre structures, forms of ice that we don't have on Earth, that we can't even form in the lab. And it's interesting because when you think about the kinds of exoplanets that are out there are a lot of Neptunes, mini Neptunes, Jupiters, hot Jupiters, that there are weird forms of ice inside of this, much more than the kinds of ice that we might have on a planet like the Earth. And so what does this ice do? How does it work? So researchers went back to first principles and looked at how these atoms might come together when you take in sort of their quantum mechanics. And what they simulated was that you should get this strange helical structure of the water as it forms under this high temperature, high pressure environment. And under even higher pressure environments, you should actually get this helical structure forming out of carbon atoms. And that hydrogen can then move along this almost like a spiral staircase through these spiral structures. And then that will influence the kind of magnetic fields that we see on Uranus and Neptune. And this is a big question. Astronomers have found that the magnetic fields on Uranus and Neptune behave differently than how they behave on Jupiter and Saturn and on Earth even. And that it might be that this is an explanation. When you've got hydrogen atoms that are moving through this structure in one direction, that this generates bizarre magnetic fields on these giant planets. Of course, to really know for sure, we're going to have to actually drill down into one of these ice giants and find out, or be able to simulate this kind of environment in the lab here on Earth. I've got a story about this from Andy Thomaswick. I hope you're enjoying this week's episode of Space Bites. Of course, you had to watch an ad to watch this episode. You might have to watch an ad at the end. We remove all the ads in the middle, so you don't have to watch any of those. But still, that is too many ads. You deserve better. And in fact, we've got a place where you can watch this entire episode without any ads at all. And to encourage you to do that, we're going to put one extra story. I'm talking about Patreon, of course. Now, you don't have to become a subscriber. You don't have to give us any money. You can just watch this episode for free right now. Go to patreon.com. We'll put a link down in the show notes. And the extra bonus story this week is all about a meteorite that has been found that is very similar to Mercury. And of course, this is still a fraction of the stories that we cover on Universe Today every week. Actually, last week, we did about 45 stories on Universe Today. I was writing my weekly email newsletter for hours and hours and hours. And yet, that is what we do to help you understand, get a big picture of everything that's going on in space and astronomy. And so now, once again, this week, I am working on this week's newsletter, which I'm going to send out on Friday. Go to universetoday.com/newsletter. It's completely free. I write every word in the newsletter. Check it out. I'm going to talk about my obsessions, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Bear Lake Roofing, Brian Bode, Caradon, Chuck Hawkins, Commander Bielek, Dark Finga, David Gilton, and David Matz, Evan Lindstrom, Evan.pro, James Clark, Janice Smith, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Marcel Sitz, Michael Purcell, Nordspace, OneStarVanimalist.org. Please follow my nephew at VBrick6994, Ren Kaidu, Richard Williams, Sean Stargent, Stephen Farley Munley, Team 49, Telescopes Canada, Vlad Shiplin, Wolfgang Klutz, and Zeldemort Galactic Defender, who support us at the Master of the Universe level. And all our patrons, all your support means universe to us. So as you probably know, the last question that I ask all of my guests is, what are you obsessed with? And the reason I do this is because I want to get a sense of what their current thinking is, what is happening right now in their brain that they can't stop thinking about, that will then turn into future missions, future research papers, or just entirely new directions that they're going to be following in their academic study. And, you know, I'm looking for those shower thoughts, those ideas that they haven't fully baked yet, but it gives me this glimpse, a sneak peek. It's like the best form of time travel that I've got. But I am also often obsessed. I ask the question because I spend so much time being obsessed about different topics. And generally, you can kind of experience it if you watch Universe Today enough. You will see these themes in the kinds of interviews that I'm doing. I might be obsessed about abiogenesis. You know, where did life come from on Earth? I might be obsessed about SETI. I might be obsessed about the center of the Milky Way, or supermassive black holes, or little red dots, or quasars. Like, it just goes on and on and on. And my mind sort of switches as I realize that there's this piece of information that I don't understand, and then I will slowly shift as I'm talking to these people, I'm filling up my knowledge, I'm satisfying my curiosity, and then something new comes along and I shift my focus onto this new thing, and that becomes my new obsession. So one of the things that I do that you probably aren't aware of is that I do in my monthly patrons only question show, I talk about what my current obsession is. And, you know, generally that will give the people who follow Universe Today a sense of where I'm steering the entire ship over the course of this last month, and sort of up until the point where I start to change my mind. Sometimes the obsessions last for a couple of months. Sometimes I've gone through a couple of obsessions to keep everyone up to date. So if you want to hear what my my answer to the question would be, check out the patrons only question show. We've got years of it now at this point. So if you sign up on Patreon at any level, you can go through the entire back catalog. You can sign up, get your own custom RSS feed so you can listen to it on whatever, phone or whatever podcast app that you use, and you can sort of catch up. Each one of these are like 4 to 5 hours long. So I hope, if you want like a lot of time to kill. And the thing that's great about the Patrons Question Show is that they're very advanced questions. So if you feel like the questions that I'm answering in the general question show or during the live streams, they're simple, you want something more advanced, you probably would enjoy the Patrons Question Show, because these are the people who have already, they already know the simple questions and the simple answers. And so they hit me with their zingers. And I have to do a bunch of research, math, homework before I'm able to answer a lot of these questions. So we're going to be posting the next Patrons Question Show in a couple of days. So now's a good time to become a patron. Go to patreon.com/universetoday. All right, we'll see you next week.